Okay, start recording. Okay. Um, previously we're already done with the this chapter 1 algebra. Okay, P3 chapter 1 algebra, chapter 2 exponential and log. Okay, now we're doing chapter 3 trigo. Okay, so let's revisit from P1 first. From P1, what have we done previously? So from P1 we already solved simple trigo. Okay, solving simple trigo. Then we also learn about basic graph and transformation. You also learn about some trigo formula, which is sine square theta plus cos square theta equals to 1, and tangent theta equals to sine theta over cos theta. Okay, so now, of course, I will assume that students already okay with the P1 syllabus. Okay, then we continue with P3. P3, first of all, let's deal with the trigo formula first. Trigo formula. Okay. So trigo formula, we actually has a formula that we can follow. Let me find the picture. Okay, first of all, we can use this picture to identify the trigo formulas. Okay, so we start with the sine A plus B cos A plus B. Okay, that it gives us a sine A cos B plus cos A sine B, cos A cos B minus sine A sine B. So this one is the very first thing that we're going to do. One here. So these two are actually happen together. So the red color is actually how everything started. Okay, the red color is how everything started. So then after that, we expanded into the tangent A plus B, tangent A minus B formula. Then we go into the double angle formula. Okay, then we go into half angle formula and the triple angle formula. Then we go into the purple color. This purple color is the important one. Okay, I'm missing, there's alpha here. Use another color. There's alpha here. Okay, then we also have the A plus B and the PQ formula. Okay, so let's see first thing first. Okay, how do we actually know the addition rule and the subtraction rule? So the first group is sine A plus B. Okay, plus minus cos of A plus minus B. So the first one, we will have sine A cos B plus minus cos A sine B. This one will equal to cos A cos B minus plus sine A sine B. Okay, so these four formulas are actually together. They actually can start from anywhere. Okay, so let's take a look. Okay, then from here, then we start to look at the formula. Okay, how to actually prove the formula. So first of all, we draw two triangle. Okay, two right angle triangle, they are being stacked together. Okay, they are being stacked together. This one is alpha, this one is beta. Therefore, together we have alpha plus beta. Okay, from these two right angle triangle that are actually being stacked together, we separate some parts. Yeah. Okay, so this one I call it point A. Okay, point B, C, D, E, F. Okay, so we have these few points. So, okay, how do I actually prove this formula? So I start with cos of alpha plus beta. So cos of alpha plus beta here from the triangle. So we can actually see from the triangle of ABE. Okay, from the triangle ABE, we actually can see that cos alpha plus beta is actually represented by AB over AE. Okay, AB over AE. Then from this AB over AE, we also can see that AB is a part of AC. So AB can be written as AC minus BC over AE here. Okay, after that, so we separate the fraction. Okay, I separate the fraction. AC over AE, BC over AE. Let's see what actually happen next. So AC then times by AE here. Okay, I'm going to the add nothing rule. I'm going to fill in add nothing rule. It's just that what I supposed to fill in. That's all. Okay, then same thing over here. So I see that AC is actually one side of the bottom triangle. Then AE is another side of the top triangle. These two triangles actually share the same side, this which is AD. Okay, so I'm going to fill in AD here. Okay, BC is actually same length as FD. So I'm going to change this and write that as FD. FD and AE. FD, I can see that is the triangle, is one side of the triangle over here for the small triangle. AE is the one side of the top triangle. Okay, these two triangles share a same side, which is DE. Okay, which is DE, so I fill in DE here. So now let's see what's going to happen to them. Okay, so AC over AD, AC and AD here, you see that if they are corresponding to angle alpha, AC is the adjacent of alpha, AD is hypotenuse of alpha, hence I have a cos alpha. AD is over here, AE is over here. AD and AE also fulfill the angle for beta, so where AD is the adjacent of beta, AE is the hypotenuse of beta. Therefore, I have a cos beta minus. Okay, FD is over here, but I have no triangle. I have no angle actually involved over here. Let's try to look at what are the angle involved. So since this is a right angle triangle, this will be 90 minus theta. Minus 90 minus alpha. This one also 90 minus alpha. Since over here this is 90 degree, so of course this one will be alpha. Okay, this will be alpha. So since this is alpha, and by looking at FD, okay, and DE over here, by corresponding to this small triangle, you see that FD is the opposite of the alpha. DE is the edges, the hypotenuse of alpha, hence I have sine alpha. And DE over here and AE over here, you will see that DE is the opposite of beta, AE is the hypotenuse of beta, hence I have a sine beta. From here you can see that cos of A plus B equals to cos A cos B minus sine A sine B. Okay, which is the addition rule. So as a further math students, you will be expected to remember the proof. Then from here, okay, what next? So from this, we start to take care of the other three. Okay, since one of them is already solved by diagram, the other three can be solved by using the relationship from P1. So what are the relationship that we can do? So cos of A minus B. Okay, so cos of A minus B, I can read it as cos of A plus negative of B. Then I will have cos of A, cos of B, okay, a cos of negative B, minus sine of A, sine of negative B. Why is it like that? Because I read it as a form of from the rule above. So cos A plus B. I read it like the rule from above. So I have a cos A plus B here. Therefore, I will have cos A, cos B minus sine A, sine B, which is following the form. I just following the form. Then from P1, cos A, of course, is just cos A itself. Cos of negative B from P1, we know that is a cos of B. Minus sine of A. From P1, sine of negative B is negative sine B. Therefore, over here, we have a cos A, cos B, plus sine A, sine B. Okay. Then, after that, what about sine? Let's talk about sine A plus B. From P1, we have sine can be written as the cos. So where cos of 90 minus A plus B. Okay, this is rule from P1. We know very sure about this. Okay, then I rearrange the form. So I write them as 90 minus A minus B. Now you see that I have the form of cos of A minus B. Okay, so where the 90 minus A here is just the A over here. So after that, I rearrange the form. Then I will get a cos of 90 minus A, cos of B, plus sine of 90 minus A, sine of B. As you can see, again, I just following the rule above. Okay, nothing special over here. I just following the rule above. So back to P1, cos of 90 minus A is sine A. This is cos B, plus sine of 90 minus A is cos A. Then this is sine B. So we have the sine of A plus B formula. And from here, we have this one tangent of A plus B. Okay, tangent of A plus B. Tangent, oh sorry, not tangent. Think too fast already. Sine of A minus B first. Sine of A minus B. Okay, we can trick it at the same way by using like the cos that we have above. So sine of A plus negative B. So that I can actually just borrow from the sine A plus B formula. So I will have a sine A cos of negative B plus cos of A sine of negative B. Then, according to the rule, sine of A, so cos of negative B, according to P1, is cos B plus cos of A. Sine of negative B from P1 is negative sine B. Therefore, I have a sine A cos B minus cos A sine B. Hence, this is the formula. Then from here, we come to the tangent A plus B. Okay, so now comes to this diagram. What exactly is this diagram actually trying to tell us? This diagram actually to tell you that how do we actually create one formula from the other. This is a flow chart. So we actually can use this flow chart to remember, to memorize like how to actually get one formula from the other. Okay, so you can see that these two are actually starting together, then comes to this, the arrow, the direction of the arrow here. Okay, so tangent of a plus b, according to P1, it will be following sine of a plus b over cos of a plus b. Therefore, we can use the formula that we have just found above. So sine of a cos of b my plus cos of a sine of b over cos of a cos of b minus sine of a sine of b. So what I'm going to do now is I'm going to make them all into tangent. In order to get tangent, I need sine over cos. Therefore, the top I will divide it by cos A cos B. The bottom I will be divided by cos A cos B. Hence, from here, you will see that the top I have sine A cos B divided by cos A cos B plus cos A cos sine B divided by cos A cos B over cos A cos B over cos A cos B minus sine A sine B over cos A cos B. Therefore, you will see that there's something that I can cancel. Cancel, 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 cancel here. And I will get tangent A plus tangent B over 1 minus tangent A tangent B. That's the answer. Okay. Whatever the proof that we actually showing here, it can be appear as a P3 questions. Okay, they can be appear as a P3 question. So tangent of A minus B. Okay, we can actually use the same trick. Okay, like what we did above. So A plus of negative B. Okay, then I have a tangent of A plus tangent of negative B over 1 minus tangent of A tangent of negative B. Okay, equals to, according to P1, tangent of negative B is negative tangent B. So I have a tangent of A plus negative of tangent B over 1 minus tangent A negative of tangent B. Therefore, I will get tangent A minus tangent B over 1 plus tangent A tangent B. Okay, to help students actually understand about the formulas is no other than doing the exercises. Okay, so let's see what are the exercises we can actually do to help students understand better. Okay, about the so students can try to do it by proving questions. Okay, by proving questions, and students can also do it by using the solving questions. Okay, solving questions. This will be the two questions that students need to do for now for this first part of the exercise. So let me put the answer as well. Okay, 7. This is exercise 7A. Question 7, question 13. Question 13. Okay, and this is the answer. Okay, so okay, we'll do this for now.